In this video, I am going to share the implementation details of my summer project. The project incorporates an implementation of a neural network from scratch in Python without the use of any libraries related to machine learning, whose code is this. This is the code of my summer project. To see the neural network in action, we needed a dataset on which we can apply it successfully. One such widely accepted dataset is the MNIST dataset of handwritten digit images. The dataset consists of images of the size 28 cross 28, which equals 784, and they are 60,000 in number. We have divided it into 40,000 training images, 10,000 validation images, and rest 10,000 to test our trained neural network. So let's start by executing the main file, which is this, of the neural network of the project. I am entering the number of layers to be 3. The neurons in subsequent layers, that is in the first one 784, second one 30, and third one 10, and learning rate to be 3.0. Number of iterations of training 20, and batch size for training 15. Now it is executing, it's training itself. This is the first iteration. We can see 89 14 images are correctly classified out of 10,000. This is 89% accuracy. And the second one is 91.2% accuracy. We can see it has increased. Then there's 92.48% accuracy, still increased. And now we shall fast forward through this because it is going to take about 2 minutes to get trained. As we can see, the accuracy of classification is increasing in each iteration, and it has converged after about 20 iterations. The graph of accuracy versus iterations can be seen here. We can see in the beginning the training is fast because the sigmoid function has high gradient, so gradient descent lets it fall into the minima fast. At later stages, the gradient reduces, and so is the effect of gradient descent. At about 20 or so iterations, it converges. Now I am going to explain how all my code is organized and working. First of all, this file like I executed it here is executed. Here we can see the inputs of all number of layers, neurons in every layer, learning rate, iteration, and batch size is input. After the input of this, we create a new network. We create a new network whose class is defined in this class. This class creates an object which passes the subsequent layers in the network. Neurons in layer, the ones we input here, and are passed in here. Now is a step for training. In this class, we have a function called train, which lies here. This function train. This function train is called for training data. That is the number of tuples of training data, the iteration, batch size, learning rate, and test data, which we have all input here. In the training we have the number of iterations, shuffling of data, generation of batches. Basically what happens is, for every iteration we shuffle the data, then we generate batches of size which we have mentioned in here, and 15, that is the batches. Then for each iteration batches are constructed. For say for example there are 90 tuples and the batch size is 15. So there will be 4 batches, 6 batches. For every batch we update self.batch. This function is called self.batch is here. Self.batch update. This is here. This function makes use of this function back propagation to update the weights, and here self.bias matrix and self.weight matrix, both of them are updated.